Okay. Vector addition, and by extension, sort of subtraction, because subtraction can be thought of adding a negative. We'll talk about, hopefully later, scaling a vector, which would include multiplying by a negative. But for now, we're just going to talk about vector addition. The classic way every textbook ever shows you how to do this is it first gives you two vectors, like vector A and vector, I kind of want to make this interesting, about vector B. And it tells you that what you need to do is take the vectors and make copies of them so they go head to tail, and then tail to tail and head to head. It would look something like this. You'd make a copy of your A vector that would be along here, make a copy of your B vector coming down head to tail, then make another copy of your B vector down at the bottom with a common tail, and make one with A again, your common head. The resulting vector, the sum, would be right through the middle. So this one here in pink would be vector A plus vector B. Now that's great, and it works, and if you happen to have a lot of time, graph paper, a ruler, and a protractor, you could actually do it that way. These days we can probably do it with electronic tools as well. But it's time consuming and not generally the way that these things are practically done. So we talked a little bit about decomposing into unit vectors, and that is in fact what you would want to do. Let's say we knew something about the two vectors. Say that A has a length of 5 units. Pardon me. And it's at an angle of, oh gosh, we can go with anything we want. How about we go with something simple? So 30 degrees. And then let's say vector B is at, it's a lot shorter. Let's call it 2 units. And it is at an angle relative to the horizontal that we would call, say, it's pretty steep. How about minus 45 degrees? Again, to keep it simple for us. All right, so if we decompose these, we would have the A vector looks like 5 cosine 30 in the I hat, 5 sine 30 degrees in the j hat. Vector B looks like 2 units, cosine 45 in the I hat, well, cosine minus 45, but cosine of minus 45 and cosine of 45 are the same thing. And then 2 sine, this one it matters more, minus 45, because sine of minus 45 is minus sine of 45. Okay. So we take and get those punched out with a calculator. 2.5 times square root 3. Oops. Keep hitting the wrong button. 2.5 times square root, not squared. 3. So this would be A is 4.330 and then some more digits. And on the other side, this will be 2.5 along the j hat. The B vector will be, well, of course, cosine 45 is root 2 over 2, so it'll be square root 2, so 1.41 I hat, and then we get a negative 1.41 j hat. Okay, I'm actually going to change this up so I have the minus in here. Mark the change in red. All right. If we add these two vectors together, we get A plus B in component form will be 5.74 in the I hat direction, and I'm going to use a calculator so I don't make a dumb mistake here. 2.5 minus 1.41 is around positive 1.09. Now this is an acceptable answer for the sum of these two vectors. It's in component form. We can always use our rules for conversion and change this over. The magnitude would just be the square root of 5.74 squared plus 1.09 squared. And then the direction of it would be inverse tan of 1.09 divided by 5.74. So let's see what we get. Square that plus 5.74 squared. Take the square root. Magnitude is 5.84 units. And the direction, 1.09 divided by 5.74 and inverse tan. I kind of went to double check this one, but it says it would be 10.8 degrees. Okay, so we could state it 5.84 units at 10.8 degrees is the sum of A plus B. Now this is really the way you always want to do it for the most part. Decompose it into x, y, z components, I hat, j hat, k hat, add the vectors in that format, and then go from there. Later when we talk about scaling, if you have something like a minus 2b, what you'd want to do is take your a vector in component form, take your b vector in component form, multiply the b vector by minus 2, and then add those together to get your result. So it's pretty straightforward. Here's one example. We had more in more when we did our lecture time, so you'll see those, or hopefully have seen those. All right. I think that's it for this. I just want to show that here's how you would do it. You'd decompose the vectors into component, into their unit vector notation. You'd add them together in that notation. And if necessary, turn it back into magnitude and direction. If you have more vectors, you just keep doing the same thing. All right.